Figure 3.1 shows the descent of a skydiver from a stationary balloon. We can see that the balloon is 2,000 meters above where the parachute has been marked 500 meters below it. So that's not necessarily ground level, but that's just during the flight of motion. Right, the skydiver steps from the balloon at a height of 2,000 meters and accelerates downwards. His speed is 52 meters per second at a height of 500. He opens the parachute. From 400 meters to ground level, he falls at constant speed. The total mass of the skydiver and his equipment is 92 kg. Calculate the loss of gravitational potential energy from 2,000 meters to 500 meters. Right, before we go any further, it's really important to define the force due to gravity. So all objects on Earth experience the same acceleration due to gravity. And usually for exams, you quote that as 9.8 newtons per kilogram. Sometimes it's rounded to 10, but it's better to use 9.8. So for every kilogram of mass, the force due to gravity is 9.8. So we need to find out the loss of potential energy from this point to this point. So we need to call upon the potential energy formula, which usually is given at the front of the exam paper, or you may have been asked to remember it. And it's an easy one, so it's GPE equals the mass of the object times gravity times height. Put in the numbers in. We have the mass of the skydiver and the equipment is 92. Gravity, we got to take as 9.8. And then the difference in height from 200 to 500 is 1500. Gives us a really large number. 1352400. Now the units of potential energy, like kinetic energy and any other form of energy, is joules. You will notice on the answer line it's left blank because you were expected to put that unit in. Number 2, the kinetic energy at the height at 500 meters. Kinetic energy formula is EK equals half mv squared. M is the mass of the object. V is the speed. So we need the speed for this. So if we go back to the description, it does say his speed at 52 meters per second at a height of 500 meters. Putting those numbers in, we end up with half times 92 times 52 squared. And again, another big number. Okay. You will notice, which sets up the next bit of the question, that the kinetic energy at 500 meters is not equal to the loss of gravitational potential energy. Explain why there is a difference. So if I just, again, grab a different color for this and look at this number, which is 1352400, and this one. There's quite a difference between those numbers. So what is the reason for this? So the reason why the potential energy, not all of the potential energy turns into kinetic energy, is because there will be energy transferred to the surroundings. I'm not going to say lost to the surroundings because energy isn't lost. It's better to think of it as being transferred to the surroundings. And obviously the main thing, if you think using a bit of common sense, is going to be this air resistance hitting the parachute and that person in the face. There's going to be loads of resistance, loads of air resistance acting upwards, slowing him down. And that's going to manifest itself as heat. It's like a form of friction, basically. That's exactly what I'm going to put down. So there will be energy transferred to surroundings as air resistance, which, as I said, is a form of friction, and friction is a form of heat. And that difference has gone to the surroundings as heat. There will be some noise as well, and so on. Puppy, state what happens to the air resistance acting on the skydiver during the fall from 2,000 meters to 500 meters. Well, let's take a step back and say at that point, he's just about to jump out of the hot air balloon. Then as he leaves that hot air balloon, he begins to fall faster and faster. Well, at that point in time, the air resistance is basically going to be close to zero until he's had time to start falling through his journey. And then the air resistance will gradually increase and get bigger and bigger as he falls further. So during that period of falling, we can say that the air resistance is going to increase. Finally, the value of the air resistance during the fall from 400 meters to the ground. If you look at this last statement here, it says he then opens his parachute. From 400 meters to ground level, he falls at constant speed. So at constant speed, the downwards force is going to be equal to the upwards force. In other words, there's not going to be any acceleration. So we need to work out what that air resistance during the fall from 400 meters is. And that value is calculated as air resistance acts upwards, and that will be a force in newtons, will be equal to the driving force, which is the downwards force, and the resultant force, so the difference between them will be 0. So there will be no acceleration. So the downwards force is now equal to the air resistance. So we need to work out the downwards force because that will give us the answer to the air resistance. So how do we do that? Well, you'll notice by the number of marks, it's just 1 mark, so it's obviously a simple calculation. So the downwards force is going to be due to the force or acceleration due to gravity. So we know that the person's mass, including the equipment, is 92 kg. And we know that the force of gravity is 9.8 newtons per kilogram. So if I just times that by 9.8 equals 901.6 newtons. So the downwards force, which is his weight basically, which is caused by the acceleration due to gravity, is equal to the upwards force of air resistance. And at that point, there is no more acceleration. The forces are balanced. And we actually say the person has reached terminal velocity. Now, you might have heard that in another part of the course. So terminal velocity is when the downwards force is equal to the upwards force, and the object cannot fall any quicker. The object in this case being the parachuter. I hope that's helpful. If you've had any value from this, please do like and subscribe. And if you need any help, just comment down below and I will get back to you.